Students, today we are going to start diazonium salt. First one we will take preparation and thereafter reaction. So now topic will be your diazonium salt. Let me take a preparation of diazonium salt. Okay. In this case, first of all, we have to take aniline and we have to prepare N2Cl on benzene ring. First we consider aniline. Now aniline reacts with the mixture of NaNO2 plus 2HCl by maintaining temperature 0 to 5 degrees Celsius. In other words, if you are not writing like this, 273 to 278 Kelvin temperature. This is in degree Celsius, this is in Kelvin temperature. So okay, when aniline reacts with mixture of sodium nitrite and hydrochloric acid by maintaining temperature 273 to 278 Kelvin, then benzene diazonium chloride is formed. How it is possible? Let me discuss. Here aniline, first of all aniline which is diluted into HCl means dissolved. Aniline is dissolved in hydrochloric acid and thereafter by maintaining the temperature 0 to 5 degree temperature and gradually adding NaNO2 sodium nitrite. So B.D.C is formed. How it is possible? Now here 2 hydrogen reacts with 2 hydrogen and 2 oxygen. Hydrogen, oxygen will be removed. So water will be removed. Thereafter here Na and Cl will be removed. So NaCl will be also removed. Now, what is remaining part of this compound? N is present, N is present, and other Cl is present. So N and Cl will form N2Cl, and this is my benzene diazonium chloride. Diazonium chloride. So my reaction was this: when aniline dissolve into hydrochloric acid and thereafter by maintaining temperature 273 to 278 Kelvin temperature and gradually sodium nitrite is adding very slowly, then benzene diazonium chloride is formed. This reaction is known as diazotization. This is my diazotization reaction. Okay. Now, after getting this benzene diazonium chloride, which is in short form B.D.C, benzene diazonium chloride. When benzene diazonium chloride is formed, then this substance which is unstable, that is why they reacts with other substance and forms variety of organic compounds. So this is converted into other organic compound. That means we can say that this is unstable and forms variety of organic compounds which forms variety of organic compounds, OC, variety of organic compounds. Okay, so what we have done, when aniline reacts with the mixture of sodium nitrite and hydrochloric acid, that means when aniline dissolve into hydrochloric acid and after maintaining temperature 0 to 5 temperature and by adding gradually sodium nitrite, we form the precipitation of benzene diazonium chloride, which is unstable, and this substance is converted into variety of organic compounds. This reaction is known as diazotization. Okay. Thereafter, we will discuss about the reaction of diazonium salt. That means the reactions of benzene diazonium chloride. Okay, here we will take benzene diazonium chloride. That means benzene ring contain N2NCl. This is my benzene diazonium chloride. In short form, we will take B.D.C. Okay, now B.D.C reacts with five other chemicals, like when benzene diazonium chloride reacts with cuprous chloride Cu2Cl2 prepared in HCl solution, Cu2Br2 which is prepared in HBr, and Cu2CN2 which is prepared in KCN. Here HCl, here HBr, but here in KCN. Now, these reactions contain which product, which yield, we will discuss. Here, first of all, when benzene diazonium chloride which reacts with the mixture of cuprous chloride and HCl, then N2 gas will be removed. First of all, N2 gas is removed. Thereafter, copper. Thereafter, here CH and Cl will remove. That means HCl will be removed. That is why here the chlorine will attack toward this benzene ring. That is why chlorobenzene will be formed. Chlorobenzene will be formed. Here, when benzene diazonium chloride reacts with the mixture of cuprous chloride and HCl, then chloro will be attacked. Here chlorine is also there. So chloro will be attacked toward this ring. That is why chlorobenzene is formed. We will write over here chlorobenzene. Similarly, we are going when benzene diazonium chloride reacts with the mixture of cuprous bromide and HBr, then bromo will be attacked toward this ring and this N2 will be removed. So N2 will be removed, then bromo will be attacked, so bromobenzene will be formed. We can write over here bromobenzene, right? And here when benzene diazonium chloride reacts with the cuprous cyanide and potassium cyanide, the mixture of cuprous cyanide and potassium cyanide, then what will happen? Then N2 will be removed first of all, and then cyano will be attacked toward this benzene ring. So cyanobenzene you can say, or benzene carbonitrile. Two names, cyanobenzene or benzene carbonitrile. Benzene carbonitrile will be formed. In this reaction, when benzene diazonium chloride reacts with Q plus chloride and HCl, then chlorobenzene is formed. When benzene diazonium chloride reacts with the mixture of Q plus bromide and HBr, then bromobenzene is formed. And when benzene diazonium chloride reacts with the mixture of Q plus cyanide and KCl, then cyanobenzene is formed. These reactions are known as Sand-Mayer reaction. This is my Sand-Mayer reaction. Okay. In all these cases, N2 will be liberated. In this reaction, N2 will be liberated and chlorine will be going with hydrogen. That is why in all cases, HCl will be removed. Here HCl, here HNCl, HCl, here KNCl, KCl. So we can say that when benzene diazonium chloride reacts with the mixture of Q plus chloride plus HCl, Q plus bromide plus HBr, and Q plus cyanide plus KCN, then chlorobenzene, bromobenzene, and cyanobenzene will form respectively. These reaction involving N2 will be removed. So we can say that in all these reactions, N2 gas will be liberated. Here you can say that N2 will be liberated. So be going upside. This phenomena will be known as Sand-Mayer reaction. Now we are moving for similarly this type of reactions, which is naming as Gattermann reaction. Gattermann. Now here copper powder HCl. Now copper powder HBr. When benzene diazonium chloride reacts with copper powder plus HCl and copper powder plus HBr, then what will form? Then here N2 will be also removed because N2 will be gas. That is why Cu reacts with Cl and forms CuCl. Here also copper powder which is mixed with HBr. In this reaction, when benzene diazonium chloride reacts with copper powder plus HBr, then N2 will be removed. Thereafter copper will remove with Cl. So here only Cl will be remaining. That is why chlorine will be attached toward this ring. That is why chlorobenzene is formed. And here bromo will be attached toward this ring. That is why we can obtain bromobenzene. This is chlorobenzene. This is bromobenzene. So here, when benzene diazonium chloride reacts with the mixture of copper powder and HCl and mixture of copper powder plus HBr, then chlorobenzene and bromobenzene will be formed. These reactions will be known as Gattermann reaction. Gattermann. So, what we have done? We have taken 5 reactions. Now, first 3 which is involving in Sand-Mayer and second 2 which is involving in Gattermann reactions. So, by this reaction we can obtain chlorobenzene, bromobenzene, cyanobenzene as well as chlorobenzene and bromobenzene. Okay. Thereafter, benzene diazonium chloride reacts with hypophosphorus acid as well as ethanol, as well as H2SO4, right? Now these type of varieties will be carried out. Here N2Cl, you know very well that this is benzene, diazonium, chloride salt. Now benzene diazonium chloride reacts with benzene diazonium chloride reacts with Ki solution, then what will form? Then N2 gas, first of all, it will be removed, liberated. Thereafter, this Cl removes with K, so KCl will be also removed. Now, iodine will be attacked toward this ring, that is why iodobenzene is formed. This is my iodobenzene. Here we will take iodobenzene. Plus, now your K and Cl will be putting over here. So we can say that when benzene diazonium chloride reacts with Ki solution, then iodobenzene will be formed. Thereafter, benzene diazonium chloride reacts with H3PO2. Now, what is the name of this compound? H3PO2 is nothing but hypophosphorus acid, or in other words, phosphinic acid. This is phosphinic acid. But by this reaction, it will convert into oxidized product. It will be converted into H3PO3. Here we will see when benzene diazonium chloride reacts with H3PO2, then hydrolysis will be carried out. So, N2 will be removed first of all. N2 will be liberated. Thereafter, 1H, 1Cl will be removed. So, HCl will be removed. Right. Now, 1O will be going toward this compound. So, H3PO2, now it will be converted into H3PO3. H3PO3. Now, one hydrogen which is remaining part, that means will be attacked toward this ring and forms benzene. So, by this reaction, benzene is obtained. When benzene diazonium chloride reacts with phosphinic acid, in other words, hypophosphorus acid, then hydrolysis is occurred. That is why one hydrogen will be removed with Cl, HCl will be removed. Thereafter, one oxygen will be going toward this compound, that is H3PO3 is formed, which is oxidized product, which is oxidized product, right? And thereafter, one HCl will be removed, HCl, so benzene is formed. Here in this reaction, benzene is formed. Thereafter, benzene diazonium chloride reacts with ethanol, CH3, CH2, OH. Then here ethanol is obtained, ethanol is to be taken, then what will form? Here we discuss. First of all, N2 will be removed. First of all, N2 will be removed. Thereafter, 1H remove with HCl. So, HCl will be removed. Now, 1H will be going toward ring. That is why benzene will be formed. Okay. So, in this reaction, benzene diazonium chloride reacts with ethanol. Then first of all, N2 gas will be liberated, H and Cl will be removed, and remaining hydrogen will be going toward this benzene ring. That means benzene will be obtained, and the remaining part of this compound will be CH3CHO, because here H is going, so remaining part will be CH3CHO. This will my also oxidized product. Okay, so by these two reaction, when benzene diazonium chloride reacts with hypophosphorus acid or phosphoric acid and ethanol, then form same product like benzene. Okay, now benzene diazonium chloride reacts with, thereafter we'll put over here H2O. When benzene diazonium chloride reacts with water at temperature of 283 Kelvin, that means 10 degree temperature you are given to this substance with water, then what will form? N2 will be liberated. Okay, thereafter H and Cl will be removed. Now OH of this water group will be attracted toward this ring, and that is why forms ring containing OH. That means phenol is obtained. By this reaction we can obtain phenol. Plus H and Cl. So we can say that when benzene diazonium chloride reacts with Ki and forms iodobenzene, benzene diazonium chloride reacts with phosphoric acid and forms benzene, benzene diazonium chloride reacts with ethanol and forms benzene, and benzene diazonium chloride reacts with water molecule, get hydrolysis at 283 Kelvin and forms phenol. So this was my diazonium salt, the reactions of diazonium salt. Now remaining reactions like with hydrofluoroboric acid, that means HBF4, as well as Azo coupling reactions. Okay. Thereafter reaction with HBF4 and thereafter Azo coupling reactions we will see. Okay, here we will take first of all benzene diazonium chloride. Here when benzene diazonium chloride reacts with HBF4, that means here hydrogen and chlorine will remove and HCl are formed. So these BF4 will be attached toward this N2. That is why we can obtain ring containing N2BF4. Now N2 having plus charge, BF4 having minus charge. This is my benzene diazonium fluoroborate. Benzene diazonium fluoroborate. Benzene diazonium fluoroborate is obtained. After obtaining this compound, when heating is given, then what will form? Then N2 gas will be liberated. N2 gas will be liberated. Thereafter BF3 molecule will be also liberated. And fluorine will be attacked. The one remaining fluorine will be attacked toward this ring. That is why fluorobenzene are obtained. Fluorobenzene obtained. now benzene diazonium chloride reacts with HbF4 and then forms benzene diazonium fluoroborate. Benzene diazonium fluoroborate. After getting this compound, when some heating is to be given, then fluorobenzene are formed. And after that, when in this reaction, if we are taking this reaction, when benzene diazonium fluoroborate is obtained, at that time sodium nitrite is given in presence of copper and some heating will be there. That is why we can obtain nitro group will be on benzene ring. How it is possible? Let me discuss. So nitrobenzene is obtained. How it is possible? Now here sodium will remove with BF4. That is why NaBF4 is obtained. Sodium will remove with BF4. Now N2 is gas which will be liberated. So only nitro will be remaining. That is why nitro attack on this benzene ring. That is why nitrobenzene are formed. So here this product is having name nitrobenzene. So we can say that by this reaction, benzene diazonium chloride gives fluorobenzene and nitrobenzene in presence of HbF4. Okay. Now these two reactions, remaining this reaction will be known as Azo coupling reaction. I will write over here Azo coupling reactions. Let me discuss. Now first of all, when benzene diazonium chloride reacts with phenol which is soluble in NaOH. In your textbook they are written OH minus. So we can conclude that when phenol in presence of OH, that means base, when phenol reacts with benzene diazonium chloride in basic media, then para-hydroxyazobenzene are formed. How it is possible? Discuss. Now here chlorine removes with this hydrogen because on OH, the para position of OH, there is hydrogen. The hydrogen will be removed with Cl. So HCl will be removed and this ring will be fused with this N2. This ring will be fused with this N2. That is why this is my benzene ring. N2 will be written like this. And here this ring and OH, this ring and this is my para-hydroxyazobenzene. Para-hydroxy and this is azobenzene. Para-hydroxy azobenzene. So benzene diazonium chloride reacts with phenol in presence of basic media, then para-hydroxyazobenzene is formed, which is orange dye. This is my orange dye. Thereafter, similarly we are getting not by phenol, we will put over here aniline. So aniline, that means it contains NH2 which is soluble in hydrochloric acid. So we will put over here HCl, but Cl will be removed, so H plus. So we can say that when aniline kept in acidic media, and reacts with benzene diazonium chloride, then what will form? Then the para position of amino contain hydrogen. This hydrogen reacts with chlorine and forms like this. Here HCl also removed. Here H and Cl will be removed. Right? So this group will be attached to this N2. So now your phenol, besides your phenol, we are given NH2. So ring contain N2 and double bond N, right? And here ring and NH2. Ring and this is amino on para position. So para amino azobenzene are formed. So para amino azobenzene are formed, and this is yellow dye. This is my yellow dye. These two dye, orange dye and yellow dye, can be put on cotton, clothes. So these two reactions are known as Azo Coupling reaction. This can be put in very fast. Benzene diazonium chloride reacts with phenol in presence of basic media, and benzene diazonium chloride reacts with aniline in presence of acidic media. Then para-hydroxyazobenzene are formed and para-aminoazobenzene are formed, which are orange dye and yellow dye respectively. These reactions are known as Azo coupling reactions. Okay.